Hi dear students, welcome to the session of Mathematics of Class 9. Today let us discuss with the chapter Surface Areas and Volumes, exercise number 13.4. So dear students, in this exercise we have to discuss about sphere and hemisphere. Regarding sphere and hemisphere, specifically regarding the surface areas. You already know that regarding a sphere, there is no Csa or Tsa. Altogether, there is only one surface, single surface. That's why we used to conclude it into a single name surface area. So we can say the surface area of a sphere, it is given by 4 pi r square, where r is what we called the radius of the sphere. And I already told you, regarding sphere and hemisphere, there is only a single dimension, and that is what radius is. So if you know radius, you can find everything regarding sphere and regarding a hemisphere. So 4 pi r square is the equation, or that's the formula to find the surface area of a square. What about hemisphere? Regarding sphere we told right now. What about hemisphere? Regarding hemisphere, we can say hemisphere means in the name itself it is there, half of sphere. So the Csa of a hemisphere, it's given by the equation 2 pi r square. Actually, it is the half of 4 pi r square, means 4 pi r square was that of the total sphere. Here it is hemisphere, so half of that one will be the Csa. What about the Tsa? Because we are studying about solid materials, right? So if this is a solid material, if this hemisphere is solid, we can see there are two typical phases. One is the cylindrical surface, another one is the flat surface. That is what it's in the shape of a circle itself. So 2 pi r square, already it is the surface area of the cylindrical surface. What about the base area? It will be pi r square because it's a circle. So adding them together, 2 pi r square plus 1 pi r square, all together we can say the total surface area, or the Tsa of a hemisphere is 3 pi r square, whereas its Csa is 2 pi r square. So these are the three equations which you have to deal with while getting into this particular exercise. Okay, now let us do one by one the problems and let us solve them by using these typical equations. That's very important. Now let's get into the very first question of exercise number 13.4. The radius of a spherical balloon increases from 7 cm to 14 cm as air is blown into the balloon. Find the ratio of the surface areas of the balloon in the two cases. So actually there are two cases. Case number 1, the balloon is 7 centimeter in radius, and now if you are trying to fill the balloon with the air, if you are trying to inflate the balloon, at the time what happens, the radius increase. You know that gradually the radius definitely will increase, right? So now the radius increased and it reached to 14 centimeters. So there are two radius. One is the initial radius, that is 7 centimeter, and after filling with air the final radius is 14 centimeter. So let us take it as R1 and R2. Let R1, small letter R1, it may be the radius of the balloon before filling it with the air, and let R2 be the radius of the balloon after filling it with air. And as far as the question is given, we can say R1, that is equal to 7 centimeter, and R2 is 14 centimeter. Actually here you have to find the ratio. So finding the ratio means the ratio of what? Ratio of surface areas. So this is already in the shape of a spherical, right? It's a spherical shape. It's in the shape of a sphere. So you have to use the equation of a sphere itself. What is the equation? It is 4 pi r square. So 4 pi r square, two times means different cases. In case 1, case 2. So numerous ways you can do. You can do like this. In case 1, you can find the surface area Tsa of this one by using the formula 4 pi r square, and then you can find the second one 4 pi r square. That's take the second radius, and from that one also you can find it. And finally what you have to do, as you have to find the ratio, you will have to divide them together. So that will become a lengthy process actually if you're going like that, but I will get you in the simpler way. Let us write ratio of the surface areas of the balloons in the two cases is equal to, okay, ratio of the surface areas of the balloon in two cases is equal to what it will be? 4 pi r square. I'm taking it as R1 square because here it is R1 divided by 4 pi R2 square. And here you know 4 and 4, pi and pi being same number, you can cancel them together. Now it is r1 square divided by r2 square. What is r1 square? It is 7. So let us write 7 into 7 divided by 14 into 14. So here 7 and 14 will get cancelled. Here 1 times, here 2 times. Similarly here also 1 time, 2 times. So here you will get 1 into 1 divided by 2 into 2. That is 1 by 4. And when you are making this into ratio, you will write the ratio is 1:4. That's very important. This is read as is to. So 1:4. That is the proportion, or that's the ratio. So finding the ratio is very easy. So if you are taking differently, in some textbooks they used to do like this. They used to calculate 4 pi r1 square, 4 into 22 by 7 into 7 into 7, and 7 will get cancelled. You will get a big number. Thereafter you have to find by using r2, you will get another surface area, and then you will get another one more bigger number. Then you have to cancel them together. You will get big number. Maybe 600 something number will come out the numerator, and a very big number will come out the denominator. But then you will have to divide them together. Why should you waste your time like that, right? There's no need to waste like this. Just go for these equations, just write like this, and when you are seeing similar terms, cut them together, and what is left there, just add them. And then after putting those equations, then if you can cancel here and there, that means if it is divisible, that's the proper way. If they are divisible by a common number, that means if they are having a common multiple, cancel them by the common multiple so that you will get in the least simplest form, and that will be the ratio. So this is the way how to deal with it. I hope you understood, right? That's it. So next question regarding this one. See, same thing, a hemispherical bowl. So that should come into your mind that it is a bowl which is made up of, which is made in the shape of a hemisphere. Okay, a hemispherical bowl made up of brass has inner diameter 10.5 centimeter. So there is a hemispherical bowl. Just imagine a bowl in your mind, which is made up of brass. It is the material which is made up of. Then the inner diameter is given. The diameter of the inner part it is given 10.5 centimeter. Okay, that much is understood. Now, what is the rest of the thing which is given? Find the cost of plating it on the inner at the rate inside at the rate of rupees 16 per 100 centimeter square. There are some particular terms which you have to focus again and again. Number one, it's a hemispherical bowl. Okay, so bring that in your mind. Just imagine a hemispherical bowl in your mind. Got it? So you got a hemispherical bowl, right? Now, thereafter what it is given? The inner diameter is given. The diameter of the inner part, because this spherical bowl, actually, you know, there is a little bit of thickness will be there, right? If you are drawing a spherical bowl, you can see like this. So this part will be the thickness, right? This much part will be the thickness. So we can say from the center to this much part, that is the inner radius. From center to the outermost part, that is the outer radius. So there are two typical types of radius. So regarding this spherical ball, the question is about the inner radius. The inner radius is given, right? The inner radius is given. Actually, the inner radius is not given. The inner diameter is given 10.5. So every time I tell you, whenever you are seeing the word diameter, keep this in your mind. We have nothing to deal with diameter. We have to convert them into radius. So here the given thing is inner diameter. Actually, D is given. It is 10.5 centimeter. You have to convert this into radius. So tell me what will be the radius. Actually, regarding this one, we can write it as 105 divided by 10. Keep it like that. That will be much more better if you are writing like that. 105 divided by 10 means you change the point. Now this is the diameter. So what will be the radius? Therefore, radius is equal to half of this one. 105 divided by 10 multiplied by 2. Half of that one. Keep it there. So don't deal with that. Keep it there. Or we can write like this: 105 divided by 10 to the 20. That's it. This much centimeter. There is no need to cut them and make it short. Just keep it there. Now, thereafter, this is the required. This is the given radius. Okay, it's the hidden radius we found it because the diameter was given, right? Okay. Now you got the radius. Now, what else is mentioned in the question? It is mentioned that you have to find the cost of tin plating it in the inside. That means if you are plating this inner portion with tin, if you are plating it with tin, which area will you plate? You will be plating the surface area, inner CSI. So you have to find the inner CSI. Tell me whether it is the inner or whether it is the outer. equation will be same itself. What is it equation? It is 2 pi r square. Here for this r, as it is inner, you have to take the inner radius. Anyhow, luckily it is given. So you can directly take from that, that's equal to 2 into 22 by 7 into what is your r? It is 105 divided by 20 into again 105 divided by 22 times, because it's r square. So you got that much. Keeping this in your mind. Now there is no need to calculate this one. Just hold on. Let's see. Towards the last we will calculate it all together. Now, anyhow, you have to find the total cost. That is what the question is. You have to find the total cost, and the cost is given like this, that you have to find the cost of tin plating in the each side at the rate of rupees 16 per 100 centimeter. For 100 centimeter square, it is 16 rupees. So cost of tin plating, how much? 100 centimeter square is equal to rupees 16. For 100 centimeter, it is 16 rupees. So what about 1 centimeter? Therefore, cost of tin plating for 1 centimeter square. For 1 centimeter square, what will be the cost? It will be 16 by 100. That much rupees. Okay, that's the cost for 1 centimeter. So what about the total cost? This is the total CSA, right? This is the total CSA. So the total CSA multiplied by this amount, because it is for 1 centimeter, it is this much. So this much centimeter square, we got it. This is the total CSA. And this total CSA should be multiplied by this one, so that you will get the total cost. So what can we conclude here? Therefore, total cost, right? Total cost is equal to this one. What is it? 2 into 22 by 7 into 105. Okay, here let me try to because when you're cancelling, nothing is going to cancel. So here, hold on there. 7 and 105. Can you cancel them together? Yeah. 7 ones are 7. Here how much times? 7 ones are 7. Again 3 is remaining. 3 5 35. 7 5s are 35. 5 times. So I'm writing it as 15. So let me bring it there. That's equal to here 2 into 22 into 15 into 105 divided by, what about the denominator? 20 into 20 into 16 divided by 100. You got it? So this much is there. Now one by one let us cancel. 15 and 20, you can cancel them in the table of 3. 5 3s are 15. 5 4s are 20. So this 2 and 4 you can cancel. Here 2 1s are 2. 2 2s are 4. Again 2 1s are 2. 2 11s are 22. What else is there? Yeah, again 20, I think you can cancel it with 105, right? Cancelling the, how much you will get? By 5, the multiple of 5, you can have 5 4s are 20. Here, how much times? 5 2s are 10, 21. 4 and 16, again you can cancel. 4 1s are 4, 4 4s are 16, that's all. So keep that 100 there itself, that will be much more better. So here it is, what else is remaining? 11 into 3 into 21 into 4. 11 into 3 into 21 into 4. The whole divided by 100. 100 is the only thing which is remaining there, right? Now, this is equal to, how can you write this one? 11 into 3, you can write is 33. 33 into 21 into 4, the whole divided by 100. When you are multiplying this in your working area, when you are multiplying them there, just multiply them together and finally you will get it as 2772. 2772 divided by 100. Instead of dividing by 100, bring 2 places here, so you can write 27.72, that much rupees. So that will be the total cost. So this is the way how to get into. So what we done? First of all, what we done here? We found the total inner CSA, because you have to plate the inner CSA of the given hemisphere. So first of all, you find the inner CSA, and thereafter it's already given in the question that for painting or for tin plating 100 centimeter square, it is 16 rupees. So you have to find for 1 centimeter, every time you have to bring like that. For 1 centimeter, what will be the cost? So if it is directly given 1 centimeter, there is no need of this step. Very straightforward, you can multiply the given CSA by the given coast, and there finally you will straightforward you will come into the answer. But here unfortunately it is given about 100 centimeters. That's the reason why we have to include one more step there. So actually like this, just by concluding, you will get towards the last, you will get as 2772. Bring 2 points back, put a dot there. Instead of dividing by 100, it will be much more easy if you're doing like that. So finally you will get it. That's it. So this is how you have to deal with. Now let's get to the next question, question number 3. A hemispherical bowl is made up of steel 0.25 centimeter thick. So just imagine again a hemispherical bowl, and the thickness of hemispherical ball is given as 0.25 centimeter. That's the thickness. Then the inner radius of the bowl. Okay, the inner radius of the bowl is the inner radius. So see here very clearly the radius itself is given, because in the previous question the diameter was given, and from there we had to find the radius, right? But here luckily straightforward the radius is given anyhow, and the radius of the bowl is 5 centimeter. Now you have to find the outer curved surface area of the bowl. You have to find the outer curved surface area of the bowl. Now tell me, a hemispherical bowl, you have to imagine that in your mind, a hemispherical bowl. Actually here the thickness of this much part, the thickness of this much part it is given here, right? This is the total thickness of that one. So regarding this thickness, what is the thickness given? It is 0.25 centimeter. That's the thickness given. Then one more thing is given. The inner radius of the bowl is 5 centimeter. Inner radius means from here up to here. It is the inner radius. The inner radius is given as 5 centimeter. And you have to find the outer curved surface, the outer curved surface area. So in the previous question, when we deal with inner curved surface area, I told we have to take the inner radius. But here the question is to find the outer curved surface area. So what you have to take? You have to take the outer radius. But my question is the outer radius given here? No, it isn't. So first of all, what we have to do? We have to find the outer radius of the hemispherical bowl. So one by one we will write what it is given. First of all, thickness of the bowl is equal to 0.25 centimeter. Inner radius, comma, r is equal to 5 centimeter. Now after writing these two things, we will come to the main point, the outer radius. Therefore outer radius is equal to, outer radius is equal to, tell me what it will be? Inner radius plus thickness. This is the thickness from here to here. So adding these two things together, that means the inner radius plus 0.25. Adding them, you will get to 5.25 centimeter. This is the outer radius. And what you want to find? You have to find the outer curved surface area. So tell me, what is the equation to find the curved surface area of a hemisphere? It is 2 pi r square. So we will write, therefore outer Csa, outer curved surface area is equal to 2 pi r square. That's equal to 2 into 22 by 7 into, multiplying this one, we can write it as 525 divided by 100 into again 525 divided by 100, means 5.25. Instead of that, I just removed the decimal place. 2 pi r square, that's why it came 2 times. Now whatever you can cancel them, and you can bring it them to the non-equation. Now while cancelling, I think 7 and 525, you can cancel them. Here 7 1 times are 7, cancelling here 7 7s are 49, then 49, 50, 51, 52, 3 is remaining, 3 5, the number is 35, 7 5s are 35, 5 times. 75 and 100, in 25th table you can cancel, because 25 3s are 75, 25 4s are 100. So 25 3 times, 25 4 times. These two you can cancel, 2 1s are 2, 2 2s are 4, 2 1s are 2, here 11 times. So all together you will get 11, and here there's a 3, then here you can see 525. All divided by what is left there, only 100 is left. You can actually cancel this 100 and 525 by using the table of 5, but when you're cancelling like that, the total 100 may not be removed, means you cannot cancel it totally. So if you're cancelling also, you may be getting 20 or 10 or something, another number you will get there, again you will have to divide. So it's better to keep it there unless and until you can cancel it totally. It's not going to get cancelled total. So it's better to keep it there and then multiply the numerator part. 11 3s are 33. 33 into 525 you have to do in the working column, and when you're doing that you will get as 17325 divided by 100. So instead of dividing by 100, what you can do? Instead of dividing by 100, bring two places from the right towards the left, put a dot there. So your answer will be 173.25. Being CSA, it will be centimeter square. And this is the outer curved surface area of the hemispherical bowl. So this is the way how to deal with. So the main thing which you have to understand is whenever you are getting a question, what is given in the question, you have to write that one. And what is required for you, means what is being asked. From that one you can understand whether your requirement is there or not. Here our requirement is the curved surface area of the outer segment. So the outer curved surface area. In order to find the outer surface area, what you have to need, the only thing which needed is the outer radius. So we searched whether the outer radius is there or not. No, it's not there. Straightforward it is not given. So the first step what we done means we found the outer surface, outer radius, and from the outer radius we found the outer curved surface area. That's it. And forget not to write the unit. The unit is very important, it plays a very important role. It is given in centimeter, because here also you can see the centimeter mentioned is in, the unit mentioned is in centimeter itself. So we will put the same centimeter here. Being area, we will take the square of that unit. So centimeter square. That's it. So that's out from today's session, exercise number 13.4. So I hope you understood today's section very well. So in the next class, we will come with the next topic and the new exercise 13.5. Till then, take care and goodbye. Have a nice day.